Good morning, boys and girls, and welcome back to Integration by Substitution Part 2, okay, of 3. All right, let's start today. What we're going to start with today is actually, it's technically Integration by Substitution. If you're following along in our book, it's actually from earlier in our book. They just show you, like, the trick. I want us to actually learn to do it the right way, so I kind of held off on this, and we're going to include it in this Integration by Substitution part. All right, but here we go. It's with our trigonometric functions. Okay, so if I want to integrate cosine of 6x dx, technically here again we've talked about that how this has an inside. We don't always write those parentheses, but this technically has an inside right here. And so because there's an inside, we could use integration by substitution to integrate this, or we should use integration by substitution to do this. I can't remember. We might have done some where we just thought about what would the antiderivative have to be and kind of adjusted. But really, this is an integration by substitution question. So the inside, I'd want to say u is 6x. And then du, the root of u, is equal to 6 dx. And so we kind of run into that situation from yesterday where, I've got a dx, I just don't have a 6 dx. So, hey, let's just divide both sides by 6. So du over 6, or 1/6 du, is equal to dx. And so now we can come back here and we could go, hey, so 1 over 6 integral cosine u du. And now we're ready to integrate this thing. Antiderivative of cosine of u is negative sine of u. Again, always plus c. I don't know if I stressed that enough yesterday, but now that we're integrating, indefinite integrals, always make sure you have a plus c. That's one of the most common mistakes. All right, and then now if we put everything together here, I get negative 1 over 6 sine u was 6x plus c. And again, if you're ever unsure, again, I don't know if I stressed this yesterday enough or at all, but take the derivative of that. It should give us what was inside our integral, right? All right. Oh, actually, in fact, as I'm doing that in my head right now, again, that's why I do this part right here. This is very important. As I'm doing that right now, well, hey, wait, the derivative of sine is cosine. So the antiderivative of cosine is just sine, no negative. Mess that up. Mess that up. So, small eraser. Well, there we go. So just get rid of that negative there. But that's why always double check yourself and fix yourself. Whew! Almost made a mistake. Good thing I stopped that. All right, here we go. Next one. All right. So again, we have an inside. We have things multiplying together. So that indicates probably a U sub integration type problem. This doesn't look that much worse than the ones we did yesterday. But you'll see it presents its own issues to us here. So we're going to start. Hey, let's say that U is 2x minus 1. Whoa, that's a freaky pen. I don't know if I like that pen. So then if I take the derivative of that, du is 2 dx. So maybe you're seeing our issues here a little bit if we're looking at this. If we're going to try to do this, the 2's not a big issue here, right? But I've got like this x over here that I don't have here in this part right here. Like the 2, we know, hey, the 2, we can du is divided by 2. I mean, we know we can do that. But I've got this extra x over here that is causing me some issues. Okay? Here's how we deal with this extra x if we have a little something extra like that. Again, we said we do not want to write something like this. Like this would be bad. I don't want to go 1/2 integral x square root of u du. That's bad. I got this extra x in here. We don't want x's and u's together ever. Okay? Bad, bad, bad. That would be bad to write. So what we're going to do, though, the way we can kind of fix this is we can come over here and we can say, hey, we can take our u equals 2x minus 1, and we can go ahead and solve for x using this. So u plus 1 equals 2x, or u plus 1 over 2 equals x. Okay? And now, back in this statement we had up here that was bad, we could actually go and enter 1/2 integral. The x is equal to u plus 1 over 2. There's my x times the square root of u. du. And now everything is in terms of u. Sorry for the bells again. They're just going off like crazy today. All right. Now, this is something that we're going to be able to simplify and go ahead and integrate. Okay, so as part of the simplification process, I think what I would do here, this u plus 1 over 2 is really like 1/2 times u plus 1. So we can pull this over or under 2, you know, all this stuff out to the very front. And so 1/2 times 1/2 is 1/4. I can pull that out. And then we have u plus 1 now times the square root of u du. But that way I've gotten rid of that fraction part, so that's a little less ugly. And now what we can do is we can distribute this u square root of u, or u to the 1/2. If I multiply everything here, if I multiply all this by u to the 1/2 now, I get 1/4 integral u to the 1/2 times u is u to the 3/2 plus u to the 1/2 du. But now this is something I can integrate just using the power rule. Let me slide up here a little bit so we have a little bit more room. All right, so integrating using our power rule, we have 1/4 times u to the 5/2 over 5/2 plus u to the 3/2 over 3/2. Again, don't forget your plus c. So this is simplifying that 1/4 times 2/5 u, which u again was 2x minus 1 to the 5/2 plus 2/3 u, which is 2x minus 1 to the 3/2 plus c. And now if I multiply all that by 1/4, I get 2 over 20. So 2x minus 1 to the 5/2. 2 over 20 is 1/10. So 2x minus 1 to the 5/2 over 10. 1/4 times 2/3 is 2 over 12, or 2x minus 1 to the 3/2 over 6. And then again, 1/4 times c is still just c. 1/4 times a constant is just some other constant, and we just use c. All right? So, a little bit crazier since we have to do this here, a little, x substitution in with our u sub to kind of get rid of that x. But you can see still not horrible. All right? Let's do that one more time. Okay, last problem. The integral of x plus 1 times the square root of 2 minus x. All right. So on this one, we kind of have two insides, so you might have to play around with this for a while, but I'm kind of going with the way we've been doing it. U generally is on the more complicated part, so, u is my, I'm going to say u is my 2 minus x. And if I do that, then du is equal to negative 1 dx. Okay? Or negative du is equal to dx. So I've got this part taken care of. The issue we're having again is with this part back here. It's got that extra x in there that I don't want. Again, I don't really want to write this as negative integral, x plus 1 times the square root of u du. Like that, the x's and u's are not a good thing. Don't do that. We got to get rid of that x plus 1. I want it in terms of u. So the way we're going to do that in terms of u is we're going to, again, grab this guy here, our original u setup, and we're going to solve this for x. So u equals 2 minus x, or if I add x to both sides, x plus u equals 2, or x equals 2 minus u. Okay? So, but you're going to go and solve for x in your original setup. And so now that I know what that is, now we can come back in this kind of setup and be like, okay, so, negative integral x is 2 minus u plus 1 times the square root of u du. And now we have everything in terms of u. But don't start integrating until you have everything in terms of one variable. Okay? All right. I might even now take this and again simplify a little bit. Negative integral 2 plus 1 is, this is really 3 minus u root u du. And then just like on the last problem now, what you might want to do is take that and distribute that u to the 1/2, or the square root of u. So negative integral 3u to the 1/2 minus u to the 3/2 du. Okay? But you're going to want to try to simplify it and make it nice as you can to go ahead and integrate. So this, be careful with this negative. You can always make sure you have like parentheses that you're going to distribute to everything, or you can just distribute it back through. But negative 3u to the 3/2 over 3/2, not plus, minus u to the 5/2 over 5/2 plus c. All right, so negative 2/3 times 3 is negative 2. U, what was u again? This is a good time to plug in. U was 2 minus x to the 3/2. I don't know how much I should be doing all at once here. Let me keep these parentheses. Negative on the outside. 2/3 times 3 is just 2. 2 minus x to the 3/2. Minus 2/5. U is 2 minus x to the 5/2 plus c. And now I'm going to distribute my negative. And so I get negative 2 times 2 minus x to the 3/2 plus 2/5 2 minus x to the 5/2. Negative times c is really negative c. But again, c is just a constant. It can be positive or a negative. So we generally just always have plus c. Like I'm not going to make that a minus c. We probably just have that as a plus c there like that. All right? When you're done. Oh boy, one more step on this one. When you're done, again, you're going to check your answers, right? Like this is a good for response answer, but they may not have this as a multiple choice answer. Slash, like if on this problem, if you were to look at the back of the book, they don't have that answer right here. We've now got to do just a tiny bit more to it. All right? So now here's what we're going to have to do to make our answer match. I want to go ahead and I'm going to factor out a GCF from this stuff right here. All right? So if I take out a GCF out of this, I would say probably you're going to want to take out this fraction. Okay? So I would take out the 2/5 because that'll pretty things up a little bit. You might even want to take out, so we're taking out that 2 as well, take out that negative. Okay? So I'm going to take out a negative 2/5 as far as the coefficient is concerned. As far as the term part is concerned, I would take out the lowest exponent. So I'm going to pull out a 2 minus x to the 3/2. Okay? So, in the front then, if I divide that by 2/5, that's going to leave me with 10. And I took out the 2 minus x to the 3/2. And, wait, sorry, I was looking at that. That looks weird. Not 10. 2/5 times 10 would give me 20 over 5, which is 4. I need a 2 in front. Negative 2/5 times 5, that's what I need in front, is going to give me negative 2. Okay, so we're left with a 5 in front. And then minus, we took out the 2/5. And now if I take out a 2 minus x to the 3/2, that leaves me with the 2 minus x to the 2/2, which is to the first, plus c. All right? So negative 2/5 times 2 minus x to the 3/2 times 5 minus 2. If I distribute this, negative 5 minus 2 is 3. Negative is a plus x plus c. Or, like the answer they had in the back of the book was negative 2/5, 2 minus x to the 3/2 times x plus 3. They just reordered those, plus c. And so, again, you might have to do some reordering of your stuff to make things match the back of the book to get your multiple choice answer. All right? Well, thanks, boys and girls. Have fun with this, and I'll see you real soon.